And we are live. Welcome everyone to this Definity and Internet Computer live stream about a super exciting new feature called VetKeys. VetKeys stands for Verifiable Encrypted Threshold Signatures, and which is kind of a mouthful and not, it's a bit complex thing, but throughout this session I hope we can dive in to untangle what this is about and describe why this is a really significant achievement and a super exciting feature going forward. And in short, it enables privacy in public blockchains and creating cryptographic keys. And with me in this session, I have Andrea Cerulli, who has been leading the development efforts within Definity. And I have Hamish Peebles from the OpenChat project, one of the OG ICP projects. And I have Dominic Letts and Hans Rempel from Diode. So this session will work like this. First I will pass the ball to Andrea and ask him to describe the VetKeys feature a little bit. I will ask him a few follow-up questions, perhaps, and then we will pass the ball to each of the two projects that have joined. And at the end, we will, if time permits, we will do a Q&A. So without further ado, please, Andrea, what is VetKeys about, and why should we care?
Thanks a lot, Christopher. Yeah, so VetKeys, as Christopher said, is a very long acronym, stands for Verifiably Encrypted Threshold Keys. And this is a new technology that we recently incorporated into the Internet Computer Protocol stack. And as Christopher said, it helps bringing essentially on-chain privacy to smart contracts. So fundamentally, what's the main thing of that this feature brings is that it enables smart contracts to generate cryptographic keys in a fully decentralized way, so really leveraging the blockchain, and but most importantly, to transport these keys out of the blockchain to their user in a completely secure way, so that not the smart contract, not the nodes operating the network actually ever see the keys. Only the end user can actually access these keys. And once the user has access to this key, they can do essentially whatever they want with those. Right? They can do signature, they can do encryption, they can encrypt data and store it on chain, for example. But it's really up to them at that point to decide what to do with these keys. And behind the scene, what this is powered to is a new threshold protocol that we integrated into the Internet Computer, and which relies on threshold cryptography. So if you know a bit about the Internet Computer, you may know that there are already a lot of threshold protocols that are supported by the Internet Computer, mostly threshold signatures. And this is another kind of this protocol. So threshold cryptography, for the ones that they don't know, is essentially a protocol that doesn't essentially keys are not essentially handled by single entities, right? And this is to avoid essentially a central point of failure, right? But keys are distributed over a network of parties, right? In order to be able to perform cryptographic operations like signing or encryption or decryption, you need essentially a threshold of parties to essentially cooperate and do some action together. And this is another type of protocol, a threshold protocol, right? In this case, is about key derivation. And the protocol at a very high level works in this way. Essentially, there's the end user, right, that wants to get a new cryptographic keys, right? And one thing they can do is that they generate like a fresh encryption key, a transport keys, right? That they can just use for this session and then just throw away, so it doesn't have to be like a persistent key, and then hand over like the public key of this transport key pair to a smart contract, a canister specifically on the Internet Computer. This canister has access to a new system API that it was just enabled a few weeks ago. And with this new system API, you can ask the network to actually derive a key on behalf of the user. And as part of the call, the canister can specify the public key of the user. Once this call is triggered, the network of nodes, specifically a subnet on the Internet Computer, will process this call and run this threshold protocol, which is called Verifiable Encrypted Threshold Key Derivation Protocol, to generate the key. In this protocol, effectively, every node in the subnet generates a share of this key, and the share of this key is already encrypted using the user public key. And the feature of the protocol also enabled to essentially, collect all these shares, combine them together, all keeping, the keys encrypted at all times. So the end result of this protocol is essentially a fully encrypted new key under the user public key that can be then returned to the canister and eventually to the user. Once the user gets back this encrypted key, they can use their own secret key to essentially decrypt the key and then use it for whatever things they want, essentially. So this is, very roughly what the protocol does. Yeah.
And when you say use the key for anything they want, what might that be?
Yeah, so one primary use case is to, for example, store encrypted data on chain, right? But this is just, one simple use case, right? I think, I guess we will hear also more about the project, right? But you could, for example, use VetKeys to do things like, I don't know, end-to-end encrypted messaging that are completely running on chain, right? But also you can also do quite more advanced protocol. For example, you can do something like secret bid auctions, right? Where you want to maybe bid on some lot, right? But you want to keep the bids to be encrypted until the final bid. So I don't know, so some sort of encrypted eBay, if you want, right, where you can bid on items, right? But you want to have the bids all to be encrypted until the end of the bidding time, right? And you can do these sort of things with VetKeys, right? Where only at the end, when things are done, the bidding is finished, right? The final winning bid is revealed, and then and only then.
Yeah. So being able to securely generate a cryptographic key that you then can use for anything you can use a cryptographic key for, which is, to my mind, is mostly anything and everything. It's super interesting, of course. This is quite a significant scientific innovation, right? And it has been a long time coming, and there has been a lot of work has gone into creating this feature. Could you sort of just describe briefly the process of creating this and the obstacles that you ran into on the way?
Right. So yeah, I mean, I have to say that the internet computer is already kind of a powerhouse of threshold cryptographic protocol, right? They've been I've been working in Infinity for many years, right? So I've been involved with essentially the development of all these cryptographic protocols. And for example, one key component of this new protocol is that there's a master key that needs to be generated and handled by this subnet, right? So and already the generation of this key needs to happen in a fully decentralized way, right? And this happens via the so-called distributed key generation protocol, right? And so, for example, the distributed key generation protocol that the VetKeys protocol uses is the same that powers many key components of the intercomputer. For example, the random tape that is used by the smart contract, but also the leader election within the consensus protocol used by the subnets of the internet computer. And this protocol have been really crafted to be very efficient for the use cases of the internet computer and really cater for the scalability that we want to have on the internet computer, right? So we are in a lucky position that we can leverage many years of the really research and development on this area, so that now integrating protocols like VetKeys becomes actually easier, right? Because I think oftentimes this threshold protocol, right, they offer you many there may be new protocols that come up that you want to integrate, right, and do something with this new fancy cryptography, right? But then set up a full system with a decentralized set of nodes that can then really do something in production is actually very challenging, right? So I think using the internet computer as kind of threshold cryptography powerhouse is actually very convenient, because we spend so much time in working on these things that now extending and providing new threshold cryptography functionality to developers and users is much simpler than starting from scratch every time, right? And then build a new decentralized ecosystem that does only a very specific thing, right?
Thanks. Yeah. The last question I have to you before moving on to OpenChat is about the threshold signatures in general. So for those that don't know how the threshold signing system work, I mean, could you go how the is it secure? Like what happens if one of the nodes? I mean, of course, it is secure. Could you describe how it is secure and what happens if nodes are malicious, and how many nodes need to be malicious before the process breaks down, etc.
Right. So that's a very good question. So the nice feature of threshold cryptography is that it gives you two things at the same time. It gives you essentially availability, right? Because this key is essentially split over multiple nodes, and you don't need all the nodes to cooperate, right? So even if some nodes are down or they are behind, right, you don't need to have them, right? And the other important aspect that as you are mentioning is really security, right? So as there's like a threshold in this scheme that defines, okay, how many nodes essentially needs to cooperate to essentially contribute to the functionality, but this threshold also is also the security threshold, right? So as long as you have fewer than this threshold malicious party, then they cannot do anything in the system, right? As soon as the number of malicious party goes over this threshold, of course they can, for example, extract the master key that is used for this operation and then attack the system effectively. Concretely for VetKeys, we use like a high security threshold. So depending on the schemes you are using, you may be, and especially depending on the distributed key generation scheme you are using, you may be confined to use threshold of 1/3 of the nodes, right? For VetKeys specifically, we are using non-interactive distributed key generation, which essentially allow us to use a high security threshold, which means that in order to be able to recover the master key, you will need to corrupt effectively 2/3 of the nodes in the network to be able to recover the master key behind this. So and this is also the high threshold is also, for example, the same threshold used for securing the root key of the internet computer is also secured by a high threshold keys that is the key that certifies all the information on the internet computer.
Yeah, and for those that are familiar with the ICP network topology, this whole VetKeys process is not run on one of the application subnets, right?
No, exactly. So again, for ones that they don't know really the architecture on the internet computer, there are multiple subnets which are effectively the shards of the internet computer blockchain. And there are subnets of different sizes depending on what's their purpose, right? The application subnet where most of the application run typically are smaller. There are at the moment typically of 13 nodes, while the VetKeys and also the other threshold signature protocols such as threshold DCDSA and threshold Schnorr are operated by larger subnets that have 34 nodes, and then there's one master subnet that has the one that contains all the metadata that is used to operate in the computer, which is currently 40 nodes. Yeah.
Cool. Thanks for that intro, that deep intro. With that, I think we'll move on and talk a bit about OpenChat, and I welcome Hamish Peebles, and please tell us a bit about your project, your project that is one of the oldest on ICP, and your role there.
Hello, yeah, thanks for having me here. Yeah, we've been going for quite a while now. That time has flown by. It's been lots of fun. So yeah, I co-founded OpenChat along with two others. We are a messaging service, much like Signal, WhatsApp, and obviously one of the kind of headline features that you would expect nowadays from a messaging app is end-to-end encryption. And a difference between us and WhatsApp and Signal and stuff is OpenChat is a web app. So you just open a browser and you log in, and you have to then be able to read all of your messages in that browser. But then you might go on another device and log in, you have to read your messages again. Whereas with WhatsApp and Signal, it's all on your phone. And so we haven't been able to do end-to-end encryption up until now because we have had no way of delivering that key to your whatever device you log in on and it needs to work on every device. We're not like Signal and WhatsApp where you have one fixed device. So it's been impossible for us to do end-to-end encryption in a secure way up until now. So we're in the process of implementing end-to-end encryption with a lot of advice from the Dfinity crypto researchers, because they know a lot more about this than we do. So that's kind of where we are now.
Yeah, because I guess you evaluated other options before settling with using actually the ICP VetKeys feature, right?
Well, realistically there aren't other options available to us, because if we had an app, then we could do the same thing that Signal and WhatsApp do, where the key is just on your device, and then the only way you can ever read messages is via they go to your device and they get decrypted. Like on WhatsApp, if you go on web.whatsapp, you can use WhatsApp on your browser, but that's simply just pulling the messages from your phone. It's not independently loading the messages. And so for us, there's just been no option up until VetKeys came along.
So how's the implementation going? Have you run into any major obstacles so far, or any surprising insights while trying out VetKeys?
Well, so at first we're just going to have the end-to-end encryption on direct chats, just because it's simpler. So we will get those out the door, because for group chats, the group membership can be changing. That every so often people can come and go, and it's not good in terms of security if say you remove a member from the chat, but then they still have a key that will work to read subsequent messages. That's a bad algorithm. And so you will need to have key rotations. It's a more complex problem to solve. So we're going to have it for direct chats first. We've been setting up kind of the because there's part of it is working out exactly how we will encrypt the messages, and I think we've been speaking with the Dfinity team, and we've made a bit of progress there for how the underlying encryption will work. But from our side, we've just been getting on with kind of setting up all of the groundwork, where we just have these encrypted messages, which are just bytes, and then the front end will decrypt them somehow. We haven't quite plugged that somehow, but we've been implementing all the rest of it. And once we're in agreement with Dfinity of how exactly the encryption will work and how key rotations will work and so on, we will then fill in that remaining bit of the implementation. But it's essentially VetKeys for us are solely a way to deliver the user's underlying key to their device. So each user will essentially have one VetKey, and that then their message encryption keys will be derived from their underlying VetKey. So they would need to make one call to get the VetKey, and then from that point on, everything just gets encrypted and decrypted using that key to derive other keys.
Yeah, in a group chat setting, you would have to rotate the encryption keys for the whole group on some schedule, or when a new user gets added or removed and so on, I guess.
Yeah.
Cool. Do you see yourself using VetKeys in other features as well? I mean, OpenChat is not only about chatting, right? It's you can add bots to OpenChat, and you have some governance functionality and so on. So
the first use case will obviously be the messaging, but then we also you can send images and video. You can do video calls, but that's using an external service. But you can send an image or a video file, or just you can send a PDF or whatever. and all of those we would want to have end-to-end encryption on as well, but they would probably use the same algorithm we end up using for the messages. We'd encrypt the message and encrypt the file using the same algorithm, just so that the whole package is encrypted, as opposed to you'd send a message that's encrypted and it has a corresponding image that just is plain. That doesn't really that doesn't sound very good compared to the competitors where everything would be encrypted. So obviously we want to be as feature rich. We want the feature to be as secure, if not more, than these competitors. But in terms of other things we'll use VetKeys for, I haven't really thought of any, but we'll see.
Yeah, so to summarize, using VetKeys for OpenChat allows the user to sort of never have to remember their key. They can always just log in on a new device and know that they can securely derive their own personal key and start communicating securely with other users, right?
Yeah, and it's definitely worth noting that with VetKeys, if you lose your device, you can still read all of your messages, provided you can regain access to your OpenChat account. So you could have an internet identity linked to your OpenChat account, or you could have a passkey that might be saved on various devices. And so if I lose my phone, my WhatsApp messages are gone, my Signal messages are gone, but I could get a new phone, and as long as I can sign into my internet identity, I can then pull down all of my OpenChat messages again, which no other competitor can do this.
Yeah, no, that's worth noting that no other competitor can do this actually. So that is the big innovation with the VetKeys.
Just because with Signal and WhatsApp and any other end-to-end encryption, any other end-to-end encrypted messaging system, the key is on your device and only on your device.
Yeah.
So if you lose your device, your key's gone, your messages you can't decrypt them. Whereas VetKeys, we can deliver the key deterministically to any device you want, and so your messages are far more durable. You can read them in many more situations where you would lose your other messages.
Thanks. Do you have anything other that you would like to add before moving on to Diode?
No, I think we've covered everything. Yeah.
Great. Thanks.
Yeah. Thank you.
Then let's welcome Dominic and Hans from Diode. You also are into chat, but not only that, right? Diode is a kind of a communications network. Perhaps you could start us off, introduce yourself and your project.
Yeah, hey everybody. I'm glad to be here, Christopher and Andrea, and great to meet you, Hamish. Good to talk with you guys about VetKeys. Yeah, so what Diode is at a very low level is a peer-to-peer communication network. In traditional environments, it's called a zero trust network, where you have fine-grained permissions that tells you what device or what user can talk to what resource or other device or user. And so that's the Diode network underlying, and the innovation really that Diode brings to zero trust networking is anchoring the backend, the database that typically defines what device is allowed talking to what other device, called the access control list. We anchor that in blockchain. And so if you're anchored in blockchain, you're able to, audit, participants can audit who can talk to who, and you basically disintermediate, you remove many different threat vectors that plague Web 2 zero trust networks that stem from the IT administrator or loss of physical control of the server. And so everything that Diode does, has a wallet. So all of the devices communicating in the system have an EVM wallet, and any wallet can communicate with any other wallet anywhere in the world, end-to-end encrypted. and can establish a tunnel basically between the different wallets. And then you can pass different things. You can pass, I can share my internet connection, or I can share a file, or I can share a chat message, or I can share, I can give this LLM access through an MCP server to this resource or whatever, right? So you can basically do not only communications, but also control plane efforts there. And so at a fundamental, that's what Diode level, that's what Diode is an encrypted communication network. And then people can build apps on top. And there's a number of different apps that have been deployed, everything from like manufacturing line OEE efficiency tools to workload management, to messaging apps, to file sharing apps, etc. But the big challenge that Diode has to deal with on every one of these applications is that when you're a peer-to-peer network, depending if you have servers in your network or if it's just devices, some of these systems only have the user devices. There's no state. And so if two people try to talk, but one person's offline, and then the other person comes offline and they don't share an online period of time, no tunnel can be established between them. And so therefore they can't share messages or files or even their presence, right? Because there is no server that's managing state. But Diode abides by the not your keys, not your coins kind of mantra, and we apply it to data, not your keys, not your data. And so what we want to do, we don't mind using, of course, online and SaaS capabilities like the internet computer and like canisters, but what we do want to make sure is that the people using and generating the data can maintain custody of their data. And internet computer canisters give us that ability. A person with a wallet can own the full life cycle of a canister, from spawning it to refilling it, to using it, et cetera, to tearing it down. And that gives full custody still to the data initiator or to the app creator of their online environment without having to, bring their own servers. And so we've been using canisters to provide these different decentralized peer-to-peer systems with state. So for message caching and that sort of thing. But we've always had to trade key material kind of out of band. Right. And so you have to like some way distribute and ratchet keys, Hamish, as you were talking about, like group chat mechanisms and ratcheting on a per message. And then how do you manage linked devices or other devices coming in is a complicated problem. And we've solved many of those with the out of band kind of key sharing. However, for new applications, you have to basically resolve the problem again. Right. And so what VetKey gives us today, and I'll let Dominic talk a little bit about our implementation today and where we want to take it into the future, is it gives us a way to actually offload the management of that so that many more applications can come online that know that they can put encrypted key material into a environment with presence, and the other devices that they trust or things in their application can get access to those without having to worry about that kind of out-of-band chain key management. So Dominic, I'll hand it over to you and you can talk a little bit about kind of how you found VetKeys and that sort of thing. But yeah, Christoph, sorry.
Yeah, so sorry, I just wanted to jump in and ask you to describe a little bit more about the project and the kind of users you have and that you envision having. What kind of users do need this high security, zero trust networks? And you call them zones, like they set up a group of users sets up a zone. What kind of users do you currently have?
Yeah, so like at a generic level, it's anyone. We say any teams using, like for example, if they're using our Diode Collab team messaging app, any teams that are interacting either in sensitive regions, right, where they may get blocked, or interacting with sensitive data that is like compliance level data. These teams are typically using, or before they're either using Signal. If it's very high security, but Signal is not set up for teams, or they're using something like Slack, and they're basically just trusting the compliance paperwork, even though the actual technology, of course, makes their data subject to Slack's business priorities, right? If Slack's business priorities are higher with responding to a governmental request about your data, they're going to provide that data. And now your data is no longer, as confidential as you may have expected. And so it's these organizations, almost any enterprise actually cares about their IP enough that this type of capability is important to them. Really, for Diode, it's an awareness problem, and just the Slack is amazing at integrations, and so increasing our ability to do integrations. And then for anyone who is building a like enterprise access to resources for LLMs, that type of use case as well is very strong for Diode. And so there's a number, but it's really about when you need to ensure that you do not have supplier risk in your connectivity. If you introduce another network, Tailscale, right, as a security network, you're introducing supplier risk. You don't run those servers, and you don't control the access control lists that can be subverted, right? With Diode, you have full self-custody control even of the control plane. And so people who don't want that exposure, which is a number of enterprises, and every individual probably desires that, it's just typically out of reach.
Yeah, if I can add to that a bit, just like based on current events, I don't know who saw that, but I'm located here in Europe, and we had this like the international criminal court, was upsetting I think the Trump administration with some things, and then they put the principal judge on the ban list, right? And so the court is using Microsoft products, right? And so Microsoft had to cut his accounts. Like Karim Khan, who is the principal judge, cannot use any of his Microsoft accounts anymore, right? And so this is the kind of third-party risk. And now all of Europe is saying, oh, now we need our own Azure competitor, and we need our own Microsoft. And I think what we want to say in this day and age of blockchain is like, there is actually a third way. You don't have to have like another Web2 company that owns everything in every country, right? That's also not a future that I think is even technically possible. Blockchain and like a permissionless system, the internet computer is the prime example of that, right? And I think we share a lot of visions there. Is a certain way to get this kind of self-custody, become independent of the third-party risk, and deploy your solutions. And this is really where I think the internet computer is contributing in great ways. And we at Diode have chosen especially network communication as like what we want to contribute to that vision, and where we have seen there's a huge gap right now in the market, and we're filling that, and we're building these flagship products together to actually showcase how you can do it, and what can be done already actually to make really nice experiences.
But in the end, you envision sort of anyone to be able to build the generic applications on top of the Diode platform. So you could see, for instance, a Microsoft Word-like application running on top of Diode for secure groups of users.
Yeah, absolutely. I mean, at the end of the day, as I said, like the Diode network is a communication network. So if you think of the Word example, it's probably when you wonder, like, I want to have like 5 people working at the same time in the document. How do they live communicate, right? Yeah. That's probably where it would be super easy to pull in Diode as like a native Web3 thing that also knows the identities, can end-to-end encrypt, and ensure you actually, like the fingers and cursors, the 5 cursors actually belong to the people you think they belong to, right?
Yeah.
So that would be the Diode part of that.
Yeah, and you described the sort of the difficulty of making sure to update state between these peer-to-peer clients when they go offline and online back again, and so on. And so before running into ICP and VetKeys, how did you solve this problem, or how did you plan to solve this problem going forward?
Yeah, so we use like a peer-to-peer network. We took a lot of inspiration from like what was there already. Like we use a Kademlia-based distribution hash tables. We use a protocol that is similar like to what BitTorrent is using for file sharing, distribution, and parts. So we use a lot. We stand on the shoulders of giants, and we have like a local first application mindset. So you either have a native mobile app or you run a native macOS app on your machine and you interact there. And then this native application is doing the communication to the rest of the network. So it's not like a primary web app, but it's actually running something natively that you can install on your Android phone, on your iOS phone, or on your computer. And it's always available, right? Because you have the data locally, you can interact with your documents, you can interact even with your chat, even if you're offline, like basically start pre-authoring your messages or pre-authoring the files. And then once you get connectivity, it starts syncing with everyone else online.
Yeah, and before ICP, how did you do this syncing? Was it just purely peer-to-peer, or did you have to run like Web 2 regular servers, or?
Exactly, right. So this is, I think Hans alluded a bit to that, but really, like, we had this problem from the very beginning, especially like in the very beginning. Like, you're the first person, you use a mobile app, you create a zone, like that's what in the Diode Collab app is. You create a zone, and then you invite your friend, right? But after you have invited your friend, you close the mobile app, right? And so now there's only two members in that zone. It's your mobile phone and your friend, and your phone is offline, right? So how does your friend ever get your message or the invite or any of that? And so this is really where, for a long time, we were looking at, like, what can we do? And we really didn't want to introduce a third-party risk, being ourselves a third-party risk. We really didn't want to say, like, Diode is hosting a server and that server is somehow that point of contact. And so when we ran into Dfinity, I think it was at one of the hackathons in Berlin, actually, and we ran across this canister approach that allows us to basically have the zone owner also be the owner of the canister. So the canister is not owned by Diode, but it is owned by the one who owns the zone as well. And that canister can be the intermediate. That's really where we started engaging with Dfinity. And that's really what improves the onboarding experience quite a lot, because now we don't have to worry about that. And these canisters can always be available. And so the connection can be established and the initial invite, and these exchanges work even if nobody else is online in your peer-to-peer group.
Yeah, and before we started using Dfinity canisters, our customers or people deploying apps had to bring on what we just called a bot, which was just a presence peer. And so they would bring on a peer that was always as part of their zone, and that peer would handle relaying, but that was a server somewhere that they had to host, or a piece of hardware that they put under their desk or whatever. And so Dfinity allows us, and canisters allows us to basically make that just a SaaS feature of these P2P apps.
Yeah, so ICP canisters allows you to move ownership over this presence functionality from some centralized corporation, in your case you, or into the hands of the individual owners, which is a great. You don't risk being put on a blacklist the same way, and so on. And then looking more deeply at VetKeys, how do you implement VetKeys in this? What role does it play?
Yeah, so like a key issue that we wanted to solve was really like this initial. I talked about that a bit. The initial exploration. So I'm being invited to a zone, and I want to join the zone, and especially in the case when nobody else is online. And so when you do that, just like from a UI and UX experience, you want to see like the zone name, maybe some description, maybe some imagery, but none of that should be public data, right? And so we always wanted to ensure that this data stays actually off-chain, or at least off-chain in a plain text format. But if nobody else is online, there's also no back channel to distribute keys a priori before you actually see the others, right? So we were stuck in the middle between, we have now these canisters and we can use them for quite a lot. So we use them for like chat message synchronization when nobody's online, because these messages were already encrypted. But this first time experience of actually being invited to the zone before you got any other data means like you have to be able to decrypt the data before you have received the decryption key from somebody else. And so this is really where VetKeys came in for the rescue, because they allow us to do exactly this. And like the client can come online, it checks in the network whether anyone else is online as well in that group. But if nobody else is online to exchange the key with, it can go reach out to the canister, do the VetKey call to generate that decryption key, and then access the metadata that the UI needs to fill in, hey, this is the zone you have been invited to, this is the owner name, this is the description of the zone, this is the icon, and whatever else in metadata there is. And so this is actually the first VetKey integration we did, and we pushed it live, and we're using it, and we are pretty happy with that.
So the feature is live at this moment.
Yeah, the keys are all out there. The smart contracts are all out there, and they are running. We have a bunch of canisters running with the code out now, and I think in our next release drop, this is actually going GA, which means like the client, as I said, like our application is a client local app, right? So it runs on your mobile phone. And so with the next update cycle, this is going to go out to everyone else. And right now it's with everyone in all the beta testers, and then it's going to go out to everyone else.
So I just wanted to say to everyone watching, listening, that if you have questions to Dominic, Hans, Hamish, or Andrea, or me, please post them in the chat, because we will round off this interview part of this stream soon, and we will hopefully have some questions we can answer before closing this thing down. But before letting Diode go, I just wanted to hear that, how you said you have implemented it. It's mostly live. You're doing testing, etc. How did the implementation go? Did you run into any surprising, benefits or drawbacks or aha moments when really starting to dig into VetKeys?
Yeah, probably. I can talk about two things that appear. For one, it's very technical, right? So it was very technical. I think getting there can be a barrier for people. I'm really happy that we made it. We pushed also some, like we use this pretty fringe programming language called Elixir, and so there was no right library to do the necessary BLS math, and so we had to port that from somewhere else, and that was fun, but we made it over there. But also the VetKeys are just like a new primitive. And so I imagine for many users, this will be like the first time they interact with this kind of math and with this kind of crypto. And that can be just some work to get there. Outside of that, it's amazing. I think once you got it and it's actually functioning, I was like, whoa, this is amazing. Like actually the math does check out at the end, and we get the key back. I was amazed, like, whoa, it actually works. Can you believe that?
Yeah, and one of the complexities with the VetKeys, or one of the things you need to consider when developing with VetKeys, is that deriving a new key is not free, right? This whole threshold process that takes place on 34 nodes costs a bit of cycles. That means that you can it's not a wise move to just derive a new key for every user, many times during one session. Did that come across as a limitation was it easy for you to work around this? I wouldn't say limitation, but that is how it works, sort of.
Yeah, I mean, that was definitely something that we came across and we were thinking about. And so in our design, that's something that we did very deliberate, where we like check the network first for like, is there any other peer available to get those keys? And only if not, then we fall back to go to use the VetKey generation, because it's more expensive, right? So that was pretty deliberate. Also in the metadata case, we basically can use one key for the metadata, and the same key can be used by anyone who has access to it. So that was definitely something we did because of that, and we wanted to learn and get some experience, and we're going to track the numbers here on what that actually means. And then as we go on to the next phase and start using VetKeys for more data, and and want to use more different VetKeys, I think this is going to guide us and guide the design quite a bit, or impact the design quite a bit. And if you can make it cheaper, that's of course always appreciated. So let us know about that.
Yeah, and one of the things that we've worked on too for canisters and any kind of cycle costing canisters is like a bill on behalf of system, so that we roll up kind of any of the refill and billing complexities into also a way that these enterprises don't have to worry about that on any specific basis. That our current billing system, our current entitlement system just handles all that. But it is then something that we have to then think about and manage on how we portray that to the users. But I think that's been also something that helps us simplify.
Yeah, maybe let me jump in. So yeah, regarding the costs, so now that we launched the feature, we are actually starting working towards improving all the threshold protocols that are running on the internet compute, not just VetKeys, but also threshold DCSA, threshold Schnorr, threshold EDSA. And as part of that effort, we also plan to reevaluate the costs. So the cost right now is really based on, assuming that there's like high utilization of this feature, like could this, cover the cost of the subnet, right? And assuming that we can actually improve, the efficiency of all this protocol, there are good chances that we could then maybe reflect also these improvements in the cost. And so maybe just I really like to take Diode because I think that they highlight something that I didn't really mention, which is I think one thing that VetKeys does really well is really about this key management and key resharing, right? Because at the end of the day, I think you can do end-to-end encryption also without using VetKeys, and in fact, Diode, I guess they were doing it very well without VetKeys, right? But I think one thing where VetKeys really helps is like sharing keys either with yourself or with others, right? And I think this key distribution and incorporating all these things into your application may be challenging, right? And one thing that VetKeys help there is really simplifying this part of the process.
Okay, let's see. I think we've covered most of what I wanted to cover with Diode as well. So thank you everyone for these conversations. Let's see if we have any questions. I think we have one question from Dexter on X, which asks, are there any negative effects or maybe some less fortunate things with using VetKeys, or some things that you should know before using VetKeys? And I think we just in part answered that
cost is really one.
the generating new keys is not free, and that will affect your need to affect your architecture. Anything else?
Yeah, the other thing maybe latency, right? I think this cost may you may have to wait, and maybe there's one actually. You need to also maybe know a bit about the internet computer to maybe also try to minimize latency, right? So essentially, the canister, it depends where latency depends on where the canister lives on the internet computer. So if it lives on the subnet that actually holds the main key, then latency actually would be rather small, right? But if your canister lives on another subnet, then there's like there's like this cross-net communication that happens on the internet computer that may be on the way, right, which requires extra latency, right? So if you really want to minimize, for example, latency, you will need to know, okay, I should actually install the canister where the key lives, so this is actually minimized. So things that one will have to be aware while using VetKeys in production.
Yeah, so latency. I'm sorry.
Oh,
yes, please.
Just for in the OpenChat case, when you search a chat, that search happens on the back end because we haven't pushed all of the messages to your device. So we might have only pushed the page of messages to your device. So when you do a search, we have a search index in the canister and we look for results there. But obviously, if the messages are encrypted, then the backend can't find any matches because it can't search the encrypted messages because it doesn't know what they are. Similarly, things like poll messages, or basically any data where the backend needs to act upon the data, you can't. So for example, right now, when you send a poll message, we've got it where each of the options comes along with how many votes each option has, but we're going to have to change that round for encrypted messages so that the encrypted bit will contain what the question was and then each of the options, and then separately unencrypted, it'll say first option has this many votes, second option has this many, and so on. So it's just something to be aware of. The back end basically can no longer operate on any of the encrypted data.
Yeah. So one could say that is sort of a limitation currently if you want to build fully secure applications, generic applications. So imagine any type of enterprise application where you need to do a lot of business logic, data validation, etc. server side, which on ICP means on canister side. Then of course, since the data, the front end pushes to the canister is encrypted, the canister cannot decrypt it because there's always the risk of one of the nodes being malicious, and decrypting the data on canister side is a security risk. But so that sort of limits currently the kind of use cases you can build using VetKeys. And we had a follow-up question here asking, would you recommend a starter developer to use them? And I would say definitely yes, but for the simpler types of use cases, which might be I as a user just want to encrypt my data and store it, like secure file storage or that kind of stuff, is really, really straightforward using VetKeys. But Andrea, do you have any insight on the next phase of making ICP more secure? We want the client to be able to encrypt data, send it over to the canister, but we also want the canister to be able to securely perform business logic.
I think this VetKeys was really kind of the first step towards increasing the privacy on chain, right? And the main thing we are now moving towards is really the usage of trusted execution environment within the network, right? So these are concretely we're looking into using SEV-SMP from AMD, right, and using these in the replicas running the internet computer. And when this will actually happen, if there was a subnet that was only relying on trusted execution environment, at that point you could also have confidentiality on the state, and this will open up much more powerful use cases. This goes in the direction of what Amish was referring, right? That at the moment if you're encrypting something, the canister cannot decrypt it, right? Because if the canister decrypts, then the privacy is removed, right? Yeah. With a trusted execution environment, what this could enable is that the canister could actually do some decryption, right? Decrypt some data and then start doing operation there, right? But still everything will be not publicly visible, right? Yeah.
But it's important to point out that you will want both client-side encryption with the help of VetKeys. Exactly. And the trusted execution environment. Those two components combined will allow for these full end-to-end secure enterprise-level applications that we envision in the future.
100%, yeah.
I think we are running out of questions.
I think there's maybe one interesting one, which is from Dexter. Is that, can you set like an expiration date to the that VetKeys can decrypt? So I didn't really go into the more technical use cases that VetKeys enable, but there are two things that the VetKeys enable. One is identity-based encryption, which ultimately means that you can encrypt to an identity. And there's also kind of an expansion of the concept of identity-based encryption, which is time lock encryption, which lets you essentially encrypt to a timestamp, for example, right? And you can set up things in a way that essentially the canister does all the access control logic, right? But it can also do very powerful checks, right, on the condition of when to release the decryption keys, right, for example. So one thing that you can do with VetKeys is that you can encrypt to a timestamp, and the canister that gates essentially the retrieval of the keys can only maybe return the decryption keys for that crypto system only, for example, when the time is passed, right? And this will essentially let you do something like, I don't know, deadman switches or time lock encryption, right, and things like that.
Cool. Yes. Definitely, and it's worth pointing out that when you're thinking VetKey architecture, there's always the canister acting as a gatekeeper, or the canister controls which user can derive what key, because the client, the front end, can never interact directly with a VetKey key derivation system. So that offers a great flexibility in what use cases you can build. Yeah, I think we are approaching the end of this. I think we should try to keep this under 1 hour. Does anyone have any final words they would like to add? Anything, any message they would like to get across to prospective VetKey and ICP developers? Silence.
Yeah, no,
I guess just at a high level, I just have really loved watching ICP invest in features that are value added for the future of self-custody internet and decentralized internet. I think that's really inspiring, and VetKeys is one of those things. Some of the other things you guys are doing with caffeine and each step that you're moving forward, we've loved being part of that journey, and intend to keep building on you guys for a long time to come.
So I think that those are a good closing words for this session. I thank everyone watching. I'm Christopher, developer evangelist at Dfinity, and I thank Hamish, Andrea, Dominic, and Hans for joining this session on VetKeys, secure key generation on the internet computer. And good luck, everyone, implementing this. And thank you, everyone.
Thank you. Bye.
Bye.
See you all. Bye-bye.
Bye, guys. Thank you.